We're in Module 6 of the novice problems, and we're looking at problem number 2. Problem number 2 is about using the analytic solver platform for sensitivity analysis and models. So let's see how we would do that. Let's go to problem 2. Here's problem 2. And as you can see, what we're asked to do here, is to use the analytic solver platform to perform the following tasks. The first thing we want to do is create a two-way data table for net income by varying revenue and cost of goods sold. Now we could normally do this just by using the two-way data tables that we've used in the past, kind of the old-fashioned way, just do it. But we can also do this with the analytic solver platform. So let's see how we do that. The first thing we have to do is we have to take the revenue and cost of goods sold and identify them as parameters that will be changing. For example, revenue will go from a low of 200,000 to a high of $1 million, and a base case of 600, and then cost of goods sold, low 25, high 75%, and base case 50%. So how do we do that? I place my cursor on the item that I want to turn into a parameter. I go to parameters, I go to sensitivity. A window opens that allows me to say, all right, what is it that you're going to be putting in there? Well, the low value is 200,000. The high value is $1 million. And the uppercase is 600,000. Now I do the same for cost of goods sold. I go to parameters. By the way, I'm in the analytic solver platform. Sensitivity again. I go from 0.25 to 0.75 to 0.5, right? So now we have this function here called sci_sen_param with its arguments, and the same here. So let's create a two-way data table. The way we do this is we go to reports, sensitivity, parameter analysis. And by the way, one of the things that's really important that you have to do is before you do this, place your cursor on the golden cell. The golden cell, of course, is net income. So let's go to reports again, sensitivity, parameters, and here's a result cell that I want, P20. I want to move it over here. Ignore what you see here. These are artifacts from another round of doing this problem. I move this over here. I've already done it. And this over here. So here are the row value and the column value for our sensitivity table. I hit OK. I want to get a two-way data table just as if I had done this by using the capabilities data what if data table, okay? So the only thing I need to do now is to create conditional formatting. I'll do that quickly to show the negative values. New rule, format cells that contain less than or equal to 0. And the ones that I've identified over here, format, here's the color I want, hit OK, and there you are. There you got it. I'll cut this and I'll paste it back into problem 2, into this area, and I'm done. Next thing to do is to create a chart with sensitivity analysis that graphically represents all this area over here, this table that I've got. So I'm going to go to Analytic Solver. I'm going to go to Charts, Sensitivity Analysis, and again, I'm given this what I want here. I've got 3 dimensions in this chart: P4, R5, and P20. P20 is this value here, the net income. P4 is revenue, and R5 is this percentage. And this is going to create a 3-dimensional graph. We'll see it in just a second. There it is. I can control the graph in some ways by changing the inclination of it. But you see here is the percentage for cost of goods sold. Here is revenue, and of course on the main axis, the x-axis over here, or excuse me, the y-axis, we've got net income. By the way, I could have done that also with just my regular Excel chart. So I grab the data here in this table. I go to Insert. I go here. I go to All Charts. There's something called a surface chart, and there it is. The surface chart is a graph that permits me to see exactly what I saw in the other. Different colors, different shapes, but on this axis I've got net income. On the other axes you'll have to follow what you've got here, but it would have been better to have grabbed the whole data set, including the percentages, and that would have given us the right values on the axes. But anyway, it can be done with Excel also to get these three-dimensional graphs. Let's go back to problem 2. So now we've done the graph. Next thing is to do the tornado diagram. To do that, I need to change a couple more things. I did the cost of goods sold. I've got variable costs, tax rate, and fixed costs also that I need to change. So what have I got? I want to change, right now I've got cost of goods sold. I want to change variable costs now. And so I need to go back to Analytic Solver, go to Parameters, go to Sensitivity, and the values are going to be 0.1, 0.3 is the high, and then 0.2 is the base. And okay, and they're in there now. Now let's do tax rate, sensitivity. Tax rate is going to be 0.25. Upper is going to be 0.42. And the base case is 34%. Hit OK. The last one is fixed cost. So I go to Parameters, Sensitivity to assign that function there. And the lower value is going to be 50,000. Upper value 150,000. Base case 100,000. Hit OK. And by the way, I had this before. It doesn't look like I'm going to be using this, so I'm going to change this back to 600,000. Just overwrite the function that was there before. Then I place my cursor on net income. I go to make sure you do this. You won't know what it is that you're trying to do. So I go to I go to Parameters, Identify, and I come up with I only want the 4 that I selected. So the 4 that I selected were the 4 on top that you see here: R5, R8, P9, and R18. Essentially what this tells me is that R5 has the biggest effect. The changes in percentages that we did has the biggest effect on net income. Here's the center position, and it moved out here, or it moved out here. Excuse me. Here's the center position right here, where it was before. And then by changing those values, it went out in this direction. And what is R5? R5 is a percent cost of goods sold. R8, what is R8? R8 looks like it's the variable cost. It is the next most sensitive value in terms of its effect on the net income. Then there's P9. P9 is equal to the fixed cost, and then finally R18 is the income tax rate, and it has the smallest value. Look how small that is. So this tells us, from a Pareto analysis point of view, this is the most important, or the highest sensitivity to changes in net income. This is next, and this is next. All right, that concludes our, by the way, I can save these parameters, and I can also copy this to a clipboard. By copying to a clipboard, then I can, move it and paste it other places that I want. So there it is, I pasted it. So we've just completed problem 2. A lot of interesting sensitivity analysis that we can do with the Analytics Solver platform in Module 6.